Hi there. Okay, so this is for the thesis students at OCAD, but also for others that are interested in seeing how lambda fibers are done. Now, I'm going to introduce Satay, who is a grad at OCAD, and she's been doing our processing of these lambda fibers, and she's going to walk through in light what actually happens in the dark. So she's going to show you basically the steps on how to do this, and then we're going to move on how the computer works with processing and how we get the files ready, and that's all part of this PowerPoint. So Satay, come on over. So she has what we're pretending to be a roll of paper, and we usually image about 10 feet at a time. And so she's going to show you basically how in the dark, so she'd be working in the dark, how she goes through developer, stop bath, and fix. Now, normally the developer is 3 minutes and 40 seconds. Now you have to remember she's just got a hardcore roll here. So you're not going to see the pulling the paper up and rolling it, but she's going to show you how she would work. So you need your gloves on there. And then how she moves it over into the stop bath, and then down into the fix. And then as we get further in, we'll actually see some live prints being done.
Okay, so first we start the timer and then put the print inside of the chemical. So we have to pull it and roll it, and keep rolling it. And then put it back in, pull it and roll it, and keep rolling it. So when it's done, when the 3 minutes or 2 minutes is done, we have to go to the stop and do the same thing in the stop. And then fix, do the same thing in the fix. And after 3 minutes in the fix, we can turn the lights on and look at the print, see if it's good or not.
Okay, so this is the part about lambda fibers, and it's part of what I think a lot of you students and other artists would be interested in knowing about. Elevator, our company, was the first company in the world that used a lambda laser exposing device to expose digital files onto photographic paper, real silver gelatin paper. So what you're seeing is basically the front end of a lambda unit, which is really 12, 13-year-old technology, even maybe 20-year-old technology, if I may be dating myself, but all the lambdas are the same, and basically what a lambda is 3 lasers in behind there in a big box that send out a beam of information from the files that you send to me or our lab, and we send it from Photoshop to a RIP unit. It's a cheetah RIP in here, which takes the information and starts making it make sense. And part of keeping everything in control, and I've shown you the calibrations, or I will in my presentation. The main thing that is of importance with any service bureau like us or any color lab in the world is they have to calibrate to neutral. They're not really interested in the color information whatsoever. That's more for when you're into profiling paper, for making profiles to best suit your images, which is not what we're doing here. What we're doing is we're setting an aim point here for the D-min or D-minimum, which would be white with detail, and D-max, which is the maximum amount of black. And we step down equal amounts, and the red, green, and blue laser has to basically balance out in each step, and it's about a log 10. If you understand log density, it's about a log 10 difference. It's not a complete half stop, it's about a third of a stop change, and there's 21 steps. So what we do is we set a D minimum, say of around log 10, and D maximum maybe 2.45 or 2.231, which then the computer generates this grayscale and tries to balance the lasers in. Highly technical, way beyond my scope, but it is what it is. So any lab that you're ever going to use in the future, you need to know that they're doing these control strips, and if they're not a place to be working at, because they're just working too loosey-goosey. So I can't even operate this machine without making this balance. So I'm going to start by taking some files that we're printing today, and we'll call them up. So basically, we have the main control image, which you see, which is of Satay, and the steps that we did in L values, which we're going to print as well. I'm going to go into here and I'm going to load from the Photoshop some images, and you'll see it's an old computer system. It's not like drag and click. So we're going to find up the jobs that I've sent over, and we find them, open directory. Oh, that wasn't sent. So we're going to go Monk Fibers, open directory. There's 3 files, click on them, load them. And what's happening right now is we're loading files to the Lambda from a secondary computer, which has checked out that everything is in 8-bit, everything is Adobe 1998, everything is flattened TIFF, Adobe 1998, 8-bit. There's no alpha channels. Very important. And even in the names of the files, you have to be very careful. Some vendors can handle certain things. Lambda does not like brackets, hyphens, stars. It just won't work with that kind of information. Why? Old technology. But to this day, I have not seen a device that will outperform the lasers in this unit. Chromera is another device. It's an LED device, and it's what other labs use, and it's a great device as well. But I don't think the lasers, they are actually LED, and I don't think the LEDs are powerful enough to expose the fiber-based paper. Ilford is trying to make the paper work, but Ilford has to make the paper work, not vice versa. So the paper has to be changed to work with the Chromeras. So now we're calling up another file. 1, 2, 3, 4. There's 4 files there. This is for a local artist, Oshin, who some of you may know, have seen some of his work. And he prints Lambda fibers. In fact, he's going to be working today with us. He's my main guy as far as Lambda fibers for the last few years. And now Satay is learning how to do this, and Paulette will be another person that works here, will be working this machine. So really there's only about 4 or 5 of us that actually know how to make this thing happen and how to do this. But I'm hoping that a few more people learn how to use it, because it's a great technology and it's wonderful prints, and you can work from your digital file. Okay, so we've loaded the Lambda paper onto the fiber paper onto the turret, and we did a cut, and you can see that's what it looks like. Fiber-based paper. It's got a little bit of a curl to it. So we're going to say that it's okay. We're going to say that we're putting in fiber, Lambda fiber, and it's say okay. Now we're going to do the calibration. So we go up into, this is like a old school color enlarger, and actually OCAD has these color enlargers, so some of you may understand this. We have it's a Durst system, so it's set up like a Durst enlarger. You have density you can change up and down here. You have yellow, cyan, yellow, magenta, and cyan, and it all works exactly the way your color enlarger works. Now, if you're dealing with black and white, you've got contrast control here. You have sharpening here, which we sharpen in Photoshop. You can rotate the images, and here is a specific area to size properly. So what we're going to do first is expose enough paper to see if the chemistry was mixed properly and we get a good control strip. So I'm just going to shrink this down in size as a test. So we're going to go say a 10 inch by 10 inch print, and we're going to say print, and it loads up into a cube. So this is what part of the cheetah rip, and you'll see it a little bit better as I go through these images. So here we're going to make a selection on here. We're going to reopen, and we're going to go into curves, and we're going to put in a predetermined curve that we do a lot of work with this, what we call a crunch. And you'll see a little tip at the blacks. A little small moot point, but it allows Oshin to get these incredible jet blacks that his work is known for. Okay, so we've got everything loaded. I checked that they're all 400 ppi. You got to remember, folks, that the name has to be simple. Okay, don't give me a lot of weird names and think that it works. Just because it works at one lab on a Chromero, or another lab on a light jet, or another lab on an inkjet machine, it works in 16 bits in some places, 8 bits in others. You need to find out from your service bureau, whoever you want to use, what are their specs. And my specs for a Lambda are pretty specific. So now we're going to do one more thing, and we're going to put in a control strip. No, we're not going to do that. We'll say okay. We're going to put in a control strip, print at 400. And now what we're going to do is unselect all, and then select all the images that we just grouped together. And this is the beauty of a RIP unit. We're going to go auto nest, optimum paper usage, and we're going to say okay. And right now it's telling me I got 8 feet of paper. I'm going to go print and ask it to stop after the nesting cycle. And what this does is automatically gang a bunch of images together. So if you don't know how to put a canvas together, or if you don't want to do that, if you just want to send me a bunch of files, all prepped properly, turn them all the right direction, I can just send them to the Lambda, send them to a specific size, and hit auto nest, and the computer will give the best paper usage to save you money. And that goes for any press and go that we do. It's kind of like it automatically does this for us. So it's trying to calculate through all those files what fits together. And you'll see when it comes out, it's all going to be abstract. Like some will be horizontal, some will be vertical, but it's just trying to save as much paper as possible. And for you, when you're doing your projects, you want to, conserve paper, because it's very expensive. So this is going to stop shortly, and it's telling me, and remember once again, this whole system runs on 72 gigabytes right here. That's not much. That's not much at all. Like, we all are carrying portable drives around with 100 gigs. So it's a bit slower, but the turtle sometimes wins a race over the rabbit. Okay, so you see it stopped. It's giving me a warning now. And now I have one grouping. It went from 7.5 feet, 7.9 feet down to 3 feet. I'm going to tag on the control strip, and that's going to be enough for them to process. So I'm going to just hit print, go to 400, and now we're getting ready to print, and it's printing. So it's setting the resolution, which is 400 ppi. It tells me as it goes through what things are being done. So resolution 400 for Lambda Fibre. color, Lambda color, you can go at 200. So you'll see prints that we made at 200 and 400 in our presentation. You be the judge, which one you think is better. I mean, I don't think there's much difference, but this machine does have to run with this paper at 400. You know, and it's very unique for that. It's setting the scanner speed, so it's getting itself set up to run the lasers now. So it's checking the old calibration right now. It's doing some math to figure out where it's going to go next. So once it's getting up to speed, everything's cycling up. And the next thing we're going to see is it's going to start setting the laser powers, I believe. And it'll go through the red, green, and blue. So this is a red, green, blue laser system. So it's setting the laser, setting the red laser power. So it needs that much power. And that's the difference between a laser system and an LED system. The LED system does not have enough power to run this black and white material. There's a green laser being set up now. And it's just taking the old numbers of the control strip and it's trying to make sure that the lasers understand that. Beyond that, I can't explain it more than that to you because it's really sophisticated. They built it once, they built it right, and whoever was behind this was a genius. Now it's sending the calibration data over to the, from the RIP to the printer. It's calculating laser tablets. You know, I mean, this is all ongoing stuff it has to do. And shortly, so just did the red lasers, doing the green lasers, and it's going to calculate the blue laser. They're all solid state lasers that are still available. The maintenance on this machine is still available. It's really expensive to have this machine looked at. It's positioning the media now. So what's happening is the paper is now going from a load position where it was down further into the machine and getting ready for the lasers to fire in. So the lasers will all fire into this one little mixing chamber, and one solid beam of light will come that's a mixture of the three lights, and it'll start going across the paper as the paper comes down and feeds in. So right now it's getting ready to do that. We'll be exposing in a few moments. And what's happening is over here, the lasers are firing this way into a collecting device, and one solid beam of light is going to come and it's going to sweep, and the machine will slowly move the paper down as it goes across. The laser will stop at 29 inches and 29 inches here. So this is 30 inches. Now it's starting to expose, and there we go. So it's telling us that it's exposing the first test image, and you can see it's got approximately 20 seconds left to do. So it's going across right now, and it's exposing in black and white, of course. It's exposing everything as it goes. So it's just a beam sweep of light going across. So the paper's coming down and it's sweeping across. Pretty amazing, eh? Okay, so you can see we're almost done. It's not a fast process, but it's pretty incredible what it's doing right now. Now remember, we are working in black and white, so what you're going to see is a black and white image, not a color. And I mean, that's pretty obvious, but I don't want you to be surprised that I've been showing you a color wedge, and we're going to make it black and white. The black and white grayscale is important for you to understand, and as you move forward in photography, another thing that's really important to understand is LAB color, lab color, because everything is based on that, from your paint chips to your Pantone systems and to everything that's in photography. All your profiles are done to Pantones, done to LAB color numbers. So you should try to learn that, and when you see these numbers that we're talking about, they are actually important. They're not deadly important, but if you want to become at expert level, you need to know them. So We're gonna say it's done. We're gonna cut the print, cut the paper, and we're gonna cut. This is 10.5 feet of paper that O'Sheen just processed. Can we just cut off that weight just there, O'Sheen, and pop out of the way? So this is where we look at the prints. Here's our calibration. That looks good, so let's cut this one and put it into the fix. So we're putting it into a second fix after we approve it here. This is great. So this is a piece that you're going to see in the presentation. Okay. Now we look at this one here. Watch your knife, please. The big mural. So I'm just going to show you how much paper O'Sheen and Satay can process at a time. And there's a Canon 5D original color capture, converted to black and white, and printed to 24 by 36 at high resolution. And this is going into a show in New York, Hudson, New York, next month. Russell Monk is the artist. So you can Google Russell Monk and you can see his work. And this is, he shoots in natural light in Mexico, in his house at Mexico, and he shoots film and he shoots digital capture. And we make the bigger prints from the digital capture, funny enough. Okay, so take that away, please. This one here is a scan. No, actually, this is digital capture as well. Okay, this one's okay. Let's take this one away. So we're just checking to see if we like them. And I like what I see so far. That away. You're only as good as what your digital workflow is. Here, I think it's fine. Let's take that away. That's not one of my favorite ones. No, that's not good. Okay, move that away. And the last one is here. And this one's going down to Los Angeles for a show in the LA Photo Fair. And right now I think we're okay, but I've got to print the tree again with yours. And then this one I'm going to print just a bit darker. So let's keep both of these, okay? Okay, that's good.